Hello everybody, how's it going? My name is Dan the Tutor. Today we're going to be talking about the law of cosines, which is my least favorite out of the two, law of sines and law of cosines. I don't like it that much because the equation's much harder than law of sines. Let's start off with the equation. The equation is, and this is just one version of it, in other words, there's different ways you can write it, and I'll explain what I mean later in this video, but the law of cosines in general says c squared equals a squared plus b squared minus 2ab cosine c. And this is assuming you have some triangle here. It doesn't have to be a right triangle, but you have angles or vertices a, b, and c, all capitals, and then the opposite sides of these are a, b, and c, all lowercase. Now the reason I'm saying opposite sides is because just look at a, for instance. A is opposite of side A, angle B is opposite of side B, and angle C is opposite of side C. That's how I named this. Now, what's actually kind of cool is if you cover up the right half of the law of cosines, this looks exactly like Pythagorean theorem, in other words, for a right triangle. So for a right triangle, yes, this is true. The law of cosines is literally Pythagorean theorem. But what I'm saying is you can't just cover it up. And you have to worry about this minus 2ab cosine c stuff whenever you don't have a right triangle. So in other words, the problems we're going to be looking at today are not right triangles. Not that it's a big deal. We're still going to solve them anyway. And one more thing I want to say about the law of cosines. You want to use the law of cosines whenever you have side, 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 or side, angle, side. And I'll explain more what I mean by that in a minute. But if you ever have one of these two triangle congruency theorems, that's when you want to use law of cosines. And then if you have the other two, ASA or AAS, this is the law of sines, which I covered in the last video, which you can take a look at. But anyways, let's look at an example. Let's say I have this triangle right here, and I give you a 26-degree angle, side length 4 here, side length 5 here. As you can see, I give you a side, an angle, and a side, so SAS. Yes, we're going to use law of cosines. Now, let me label this triangle for us as well. I'm going to label this triangle angle A, angle B, angle C, which then makes this lowercase a, lowercase b, and lowercase c. And the goal of using the law of cosines is to find any angle or any side of the triangle. As a matter of fact, we're going to be finding all three in this video. And we very well may be using the law of sines because it's sometimes easier than the law of cosines, believe me. So the first thing I want to say is we're not going to use the equation I said at the very beginning. Why not? Because, well, hold on, let me write it. Because if I try and fill it in, lowercase c is 4, so 4 squared, equals a, which is unknown, plus b, which is 5, minus 2 times a, which is unknown, times b is 5, times the cosine of c, which is also unknown. The problem is I have too many unknowns here. I don't know a, and I don't know c. So that's going to be a problem. I can't use this equation to solve. So let me erase it real quick, and let me tell you the equation we're going to use instead that looks very similar. So first of all, since I only have angle A, we're going to be using, instead of cosine C, we're going to be using cosine A. That also means I'm going to be switching everything with a C. I'm going to be switching that with A. And let me just rewrite the formula to show you what I'm talking about. So I'm saying wherever I see a C, I'm replacing it with A because I have the angle for A. In other words, this is now cosine A. This isn't C squared anymore. It's lowercase a squared. And now I'm going to switch the A's with my C's. In other words, that A squared becomes C squared plus B squared minus 2CB cosine A. So whether you agree or not, this is the same formula. I just changed the letters around to solve for A this time instead of for C. And that's perfectly fine. You do whatever you want. Typically, you always want to choose the angle in the middle, which in this case was 26 degrees. Or if you don't have an angle and you have three sides, like the SSS theorem, then you literally can't go wrong. You can choose any of the three you want. So now what I'm saying is, side A is what I'm solving for. A squared equals C squared, which we said C was 4 squared, plus B is 5, so 5 squared, minus 2 times C, which is 4, times B, which is 5, times the cosine of my angle, which is 26 degrees. So the right side, I can plug the entire thing in my calculator, as long as your calculator's in degrees. So 4 squared plus 5 squared minus 2 times 4 times 5 times cosine 26. I plug the whole thing in my calculator, and I get 5.048. And then all I need to do is take the square root of that, and I'll get my side A. And the answer is 2.25. There we go. There's my side A. So that's 2.25. As you can see here, I'm still missing two angles. I'm missing angle C and angle B. And you can use, at this point, either law of cosines or law of sines to solve it. And let me show you why you can use law of sines and why it's definitely the easier one. If you remember, law of sines says, for instance, sine A over A equals sine B over B. And you can also do that with C as well. I'm just going to do B for this example. So A is 26 and 2.25. So sine 26 over 2.25 equals the sine of B, which I don't know angle B. That's what I would be solving for here. And then divided by side B, which is 5. Okay. So if you want to solve for sine B, you would just cross multiply. You'd get 5 times the sine of 26 degrees equals 2.25 times the sine of B. And then to solve for sine B, I gotta divide both sides by 2.25. So in other words, the sine of B equals 5 times the sine of 26 divided by 2.25, and I'll get 0.976. And now if you want to solve for B, do not divide by sine. That doesn't make any sense, and your calculator will agree with me. Your calculator will say syntax error if you try and do that. So don't do that. That's silly. Instead, what I'm going to recommend we do is we take the arc sine of both sides. So in other words, B is going to be the arc sine or inverse sine of 0.976. And I plug that in my calculator, and we'll get an answer of 77.3 degrees. And there, now we have angle B. And if you want to know the easiest way now to find the last angle, which is angle C, now that we know this is 77.3 degrees, well, we know that all triangles have to add up to 180 degrees. So, in other words, 26 plus 77.3, that's going to be 103.3. And then I'm saying 180 minus 103.3 is going to be 76.7 degrees, and that's my angle C that I was missing. And there we go, we just solved the triangle. How much fun was that? Don't actually answer that question. And now let's look at two more problems using the law of cosines. For this one, I have a triangle that looks like this. I'm going to tell you this side is 5, this side is 11, and this side is 14. As you can see, we clearly have SSS because I gave us all the sides. And let's say my triangle is A, B, C, like this, which then means 11 is lowercase a, 5 is lowercase b, and 14 is lowercase c. And so now if you want to use law of cosines, I encourage you to try it on your own first. You can pause the video, see if you can get it. But specifically, I want you to find, let's say, angle B this time. I just want to find angle B. How would you do it? Pause the video, I'll give you a second. Okay, now here's the solution. So since I want to solve for B, that means I'm going to do the version where I'm solving for B, like lowercase b squared equals a squared plus c squared minus 2ac times cosine b. Hopefully you're starting to get it now. So b squared is going to be 5 squared equals 11 squared plus 14 squared minus 2 times 11 times 14 times cosine b. And now I got to try and solve for b. This one's not going to be as easy as the last one in terms of the algebra, but that's fine. So 5 squared is 25 equals 11 squared, 121, plus 14 squared, 196, minus 2 times 11 is 22, 22 times 14 is 308, and that's times the cosine of b. And so now if I want to solve for cosine b, first I'm going to do 121 plus 196, that's 317. So 25 equals 317 minus 308 cosine b. Then I'm going to subtract 317 from both sides, like this. I'll get a negative number. That's fine. That's expected, actually. And so now I'm at negative 292 equals negative 308 cosine B. Divide both sides by negative 308. And I'll get 0.948 equals the cosine of B. And so then I just need to take the arc cosine of this. So arc cosine of 0.948 is equal to B. And that's going to be 18.55 degrees equals B. And there we go. And of course, you can solve for the rest of this triangle if you'd like. I'm just going to move on to one more example, though. And the last example I have today is I have this triangle here. This side length is 12. This side length is 10. And this angle in the corner is 80 degrees. And let's say this is A, B, and C. Now again, this time you can try it on your own, and I would like to solve for angle A, but my hint to you is that you cannot do this problem in one step. In other words, if you use law of cosines, it's not going to be used to find angle A. Why don't you think about it for a minute, try and figure out how you can find angle A in two equations, and then unpause the video and see the solution. Okay, so are you ready? Here we go. First of all, since I gave us angle C, it means that I gotta find side length C first. So that means that I'm using the equation C squared equals A squared plus B squared minus 2AB cosine C. That means C squared equals A is 12 and B is 10, because again it's opposite those angles. So C squared equals 12 squared plus 10 squared minus 2 times 12 times 10 times cosine of 80. Then I can plug the entire right side in my calculator in one step. And I will get C squared equals 202.3. Then I just need to take the square root of that. And I will get C equals 14.2. So now we found C, but now we need to find A. And at this point, you can use anything you want to find A. You can use law of cosines. You can use law of sines. It doesn't matter. Law of sines is definitely faster. So that's what I'm going to be using, but you can use whatever you want. So specifically, I'm saying sine A over A equals, you can do B or C. I'll choose B. So sine A, which is what I'm solving for, divided by side A is 12. Actually, that's a lie. I can't do sine B. I don't have angle B, so don't do that one. Do sine C over C. Much better. So sine A over 12 equals the sine of 80 degrees over 14.2. Then if you want to solve for A, you cross multiply. We get 14.2 sine A equals 12 times sine 80 degrees. That means dividing both sides by 14.2, we're going to get this. I plug the right side in my calculator, and I will get the sine of A is equal to 0.831. And then the last thing we do is we take the arc sine of both sides, or inverse sine, to find the actual angle. And I got a final answer of angle A is 56.2 degrees. And there we go. That's it for the law of cosines. So in the next video, we're going to be talking about the hardest case of all, which is the ambiguous case of the law of sines, which is an SSA triangle, which I would never, ever in a million years spell backwards. And so I'll cover that in that video. Stay tuned. Have a great rest of your day, and bye-bye.